Hi everyone. Today I'm going to give you a recap of 2025. I'm going to just let you know about what we've been doing at the BCIT Center for Welding Technology and Metallurgy Research. So we've been working with the Motion and Power Electronics Control Lab from SFU, and we've been trying to integrate AI into robotic welding. So on this project with C-SPAN, a key project that I'm focusing on is basically using embedded AI agents in robotic welding along with computer vision. And to explain the relevance of this, I would begin by basically just mentioning that C-SPAN, they have like a robotic system from Inrotech. However, they do face challenges with setup time, meaning when they're welding different work pieces, the programming time is basically a burden because the robot has to be reprogrammed. However, they've tried to address this by integrating like vision systems, although it still remains a challenge. And another issue is that the people that should operate these robots, they need to be like well trained. In most of the cases, they are not fully trained, and so the system is also not fully exploited. So this is actually the barrier that we're trying to address to improve the human-robot interaction by using AI agents in robotic welding. So I'm going to just give you a demo from basically NASA. So earlier during the year, they had an implementation of an AI agent and the robot operating system agent. And yeah, you can just see it through this video.
All right, go ahead and walk forward about a meter and turn 15 degrees to the left.
I'll move forward 1 meter and turn 15 degrees to the left. Please confirm.
Yeah, it's safe. Go ahead.
I've moved forward 1 meter and turned 15 degrees to the left.
All right, can you describe what you see in the camera?
I see an open sandy area with large rocks scattered around. Trees are 20 meters to the left, and buildings are 25 meters ahead to the right.
Okay, that actually sounds pretty interesting. Can you show me the camera feed?
The camera feed is live. What's next?
Okay, so in what you just saw, its architecture looks something like this. I'm not gonna go into all the details of it. If you want to know more, you can look at the paper, which is referenced here. And basically, at its core, I would say there's the large language model, which I can say we can use like the existing ones, but we can also, instead of using large language models, we can use like small language models and custom train them for specific tasks, which is more applicable in the case of embedded systems. Nonetheless, to explain how it works, you'd have a user give the system a query. So in our case, what would happen is you would tell the robot, for instance, to weld a fillet joint of a particular thickness, let's say, with particular welding parameters. And this query with a set of tools is going to be sent to the large language model. So these tools are basically functions that have been predefined for performing specific tasks, such as moving the robot joint. And so what happens is when the LLM receives this query, it's going to process it and it's going to make a decision on what tool should be called. So it basically sends the tool call back to the system, and the system is the one that actually does the tool call, the tool basically the action where the function is executed. And then basically we're gonna get like a status report, which could be something like encoder reading, telling us if we've reached the desired goal or not. And then this will then be fed back by the system to the LLM. And here, basically, the user can either continue to interact with it or the task can be deemed as a success. So overall, what we want to do is break the barrier of traditional robot programming, in particular in the case of robotic welding, by introducing large language models and vision language models. So we would have like a robot just like the one here, and with its vision system, we're able to see the kind of joints that are in front of us. And the welder, over time, they're able to tell the robot that these joints should be welded with a particular set of parameters. And so eventually the vision will believe that this can be used as something to train the robot, and at the same time it can be used as something for breaking that barrier for human-robot interaction. And so I'm just gonna give an update on basically what we've been able to do so far. So we've been able to just kind of like set up a system. So we have like the Lincoln R450 power wave, and we also have the Fanuc CRX10i cobot. And so what we've been able to do is we've been able to develop like a ROS2 driver for this, and that allows us to basically interact with this robot. And at the same time, we've also developed like some software driver for this Lincoln power wave, allowing us to have full control over it for robotic integration purpose. And we also have like this Xiris camera, which is mostly used like for weld monitoring. So next, I'll give you some videos that just give demos of some of the work that we've been doing.